Okay, 6-7, we're going to do problem 38. Give me the specs on it. Okay, it's a secant function. Write an equation. Okay, what else? Period. Well, it says the period's pi. Okay, what else? Okay, what else? Okay, vertical shift is -10. Okay, so we have to use this. Does it say anything about an amplitude? Oh yeah, secant usually we're not going to worry about that. Okay, so here we go, you guys. We have a secant function. We have a period, a phase shift, and a vertical shift. We know, okay, that we have the way this is going to look is y equals secant of k times theta minus c plus h, right? What did I leave out? Yeah, I left out the amplitude because there is no amplitude. I mean, the amplitude's 1, okay? Because it's 1 times the secant. So, yeah. So we're going to use the formula. Period equals 2 pi over k. Now, we know the period. What is the period? Pi. Now, why did I use this formula right here? That's the one we've been using for sine and cosine. Yeah. Why did I use this formula for this one, you guys?
That's the only way to find out what k is.
Yeah. But why didn't I use the p equals pi over k? What is the period of the secant function? No, what is a period of a regular sine function that hasn't been changed? It's 2 pi. Remember, what are the 4 that are always 2 pi? Cosine, sine, cosecant, and secant. So the other 2 that have a period of pi are tangent and cotangent. So when I do this on a tangent or cotangent, I'm telling you this for those other problems. Trevor, when you do this for the other assignment, for tangent and cotangent functions, instead of using p equals 2 pi over k, you're going to use p equals pi over k because the period of a tangent or cotangent function is pi rather than 2 pi. Yep, tan and cotan are. Yeah. Okay. So, yeah, right here, you guys, if I solve this for k, I'm going to get k equals 2, right? So now we know k. So if we're writing this equation right here, y equals secant of 2 theta. Okay. Now I need to find the phase shift. Okay, we have the formula. Phase shift equals c over k. So we know what the phase shift is. So we can substitute it with negative pi force equals c over 2. Good. Times both sides by 2. We could, if c's on the bottom, I have you cross multiply, but if it's not, we don't do that. So those cancel out, and so c is equal to what? Negative pi halves, right? Because that simplifies. So if it's negative pi halves, what am I going to write next? Plus pi halves. Why is it plus? Because it was minus a negative pi halves, which is plus pi halves. Okay, vertical shift should be easy. What's it going to shift? Down 10, right? So minus 10. That's my answer. That's all I'm doing on those. Okay? So, yeah. So that's basically it. You just need to know the most important thing you guys know. This formula for phase shift stays the same on all 6 functions. But this formula for period switches. The 2 pi is sometimes pi. When is it pi again? Cotangent and tangent. Okay. So for cotangent tangent, it would be period equals pi over k. Got it? Because that's what the period of a cotangent or tangent function is pi. Got it? Okay. So when you write these equations, just write out the standard form of it like that, and then just fill in the information that you have. That's all you're going to do. Usually on the tangent, cotangent cosecant and secant, we don't worry about amplitude because all it does is vertically stretches the graph or shrinks it. It's not like a sine or cosine that makes it go up higher or lower, okay? So we're not going to mess around with that as much on these. So we're not going to worry about amplitude on those. All right. Is there another question? Okay. Hey, you guys, we don't have an assignment to turn in today because we turned in 6-5 last time. We skipped 6-6, and I'd given you 2 times on 6-5, and we turned that in last time. So, so 2 classes ago, we didn't assign assignment, in other words. Yes? Yeah, let me do one of those. Which one do you want me to do? Cotangent of -5 pi. Okay? Okay, so number 18 on 6-7. It's asking me to find the cotangent of -5 pi, right? Now, do you remember what the graph of the cotangent looks like? Okay. Basically, in all these, you need to see, like on the cotangent, you want to find out where the x-intercepts are, and you want to find out where the asymptotes are. It's probably going to be one of those 2 things right there. Okay, so let me change this over right here. Okay, so I'm going to go right here to my screen. I'm going to put in cotangent. It says use the graph, right? So I use the graph, which is 1 divided by the tangent of x. And my window is already set. My mode is already in radians, so I'm ready to graph it. That's what it looks like. Now, I want you to notice right here that this graph only goes to -2 pi right here, right? Do you see that, Trayson? It only goes to -2 pi. We know this is pi right here. We know this is 0. We know this is 1 pi. No, -pi, 0, 1 pi, 2 pi. Now, what's happening at every pi? There is an asymptote, right? So if there's an asymptote at every pi, what do you think is going to happen out at -5 pi? There's going to be an asymptote. So this is undefined. So that's what I want you to do, is look at the graph and see the pattern. And that's why it's giving you some that aren't between -2 pi and +2 pi, is because it wants you to see the pattern and say, oh, well, every pi units, it's going to be an asymptote, so it's going to be undefined at those points. Let me show them one more thing, Julie, before I answer your question. Okay, so look over here. You can also use the unit circle chart, right? Cotangent is defined to be y over x, right? You'll notice cotangent is defined x over y, sorry. X over y would be 1 divided by 0 right here, and -1 divided by 0 right here, which is division by 0 is undefined. So every time you go around to pi, 2 pi, 3 pi, 4 pi, it's undefined. Same thing as if you went in the negative direction. -pi, -2 pi, -3 pi, -4 pi, -5 pi. I'm going to end up right there, and it's going to be -1 divided by 0, which is undefined. So you can look at the unit circle and do it, but it wanted you to see it on the graph rather than on the unit circle. Okay? We learned how to do it on the unit circle a little bit ago. Now we're doing it on the graph by looking for patterns. All those first 6 questions is finding patterns. That's all it is. Okay? Julie, do you have your mode in radians and you have your window set at this window right here? Okay. You got -2 pi to +2 pi, and you got pi force as your x scale. -5 to +5 as your y min and y max. Yeah, you guys, for viewing For viewing any trig function, usually negative 2 pi to positive 2 pi is kind of like a standard window for it. If you hit zoom trig on your calculator, it would give you a standard, what they think is a standard window, but it's not. It doesn't go to negative 2 pi and positive 2 pi. It goes a little bit less than that, I think. Still not doing it. Let me see. Yeah, wherever it hits, wherever it crosses the x-axis. So, so what number is that again? 21 through what? 21 through 26? Wasn't it 18? Wasn't it 18 you're talking about? 21 through 26. Okay. So on those problems right there, so like on 21 where it asks tangent of theta equals 0. Well, let me just talk about this one. Tangent of theta equals 0. All it wants to know is if I put in the tangent function. So let's go put in the tangent function instead of the cotangent function. Okay, this is, remember the other day when we were writing all the characteristics of all the graphs? Well, in this case right here, it's wanting to know for which values is the tangent theta 0. In other words, is the y value 0? Well, the y value is 0 at the x-intercepts, right? All the x-intercepts. Well, where is it crossing the x-axis at? Pi. At all the multiples of pi. So pi times k, where k is an integer. K is an integer. Well, you have to tell what it means. Like in the book, you'll notice it'll say. I don't know why some guy used k. Well, k kind of means constant, starts with a C, I know, but it starts with a K sound, so maybe that's why. I'm not sure. So pi times k, where k is an integer. Well, if you just did it the first time, then we'll always assume that it's an integer. Okay? Julie. Which number again? Cosecant of theta equals -1. Okay, did you look at the cosecant function? How do you put cosecant in your calculator? Okay, so 1 over sine. So 1 divided by the sine of x. This is number 23, right? Okay, so here's a cosecant function, and it wants to know cosecant of theta equals -1. Where is the cosecant of -1? Well, right there it's a -1, right? And right there it's a -1. Do you see those? Well, where is this one? What's this x value? And this is -pi/2. And what's this one? This is 3pi/2. Okay? And so we could describe it in a couple different ways. How did you say they described it in the back of the book? Yeah. So when they say it like that, they're basically saying, if you say 3pi/2 plus 2pi/k, you will notice, yeah, you'll notice that the distance between -pi/2 and +pi/2 right there is a distance of 2 pi, right? So they started at 3pi/2, and if k is 1, well, if k is 0, 2 pi times 0 is 0, and you just get 3pi/2, you get that one. But if k is 1, you're going to get 3pi/2 plus 2 pi. It's going to add 2 pi to that, so it's going to go clear out to 7pi/2. Okay? And if k is 2, it's going to go to 11pi/2. Whereas if k is -1, it's going to go to -pi/2 back this way, 2 pi. It's just going to add or subtract 2 pi, however how many times you make k. Got it? So that's why they put the answer like that. Okay, we're going to move on to the assignment. So we have got talked about inverses today. Okay, so today The objective is to graph inverse functions and to find values of inverse trig functions. Now, we've kind of already done this, you guys. We have been doing this. But we've been doing it by asking this question right here, just like on the bell work today. Sine of theta equals 1/2. That's how I've been asking the question. Can anybody tell me what theta would be? Sine of what angle is 1/2 is what it's asking, right? What is it? Don't use your calculator. Look at the unit circles. What is the unit circles? 30 degrees, right? This is how we've been doing it. Today we're going to change that. We're going to write it like this. The sine inverse of 1/2 equals what angle? It means the same thing, okay? Have I showed you the notation for inverse yet? Like that? Yeah, we have. So the sine inverse of 1/2, it doesn't mean having to do with cosine. It means this right here means the same as this right here. It's just asking it in a different way. The sine of what angle is 1/2? If we solve for theta, if we get theta by itself, it's going to say sine inverse of 1/2 equals theta. So it's still saying the sine is 1/2. What is the angle that makes that sine? Okay? So these two things are saying the exact same thing. Okay, Julie? Sine inverse does not mean cosecant, you guys, because cosecant means 1 over sine. That's called a reciprocal, not an inverse. Do you guys understand that? That's the biggest thing students do. The biggest mistake students do is they think it's reciprocal and inverse mean the same thing, but they don't. Okay? They do not mean the same thing. Okay, so that's where we're going today with this. That's not right. Okay, now the other thing we're going to do is I might not ask it like this. I might give you something like this and say, okay, y equals the sine of theta. That's the function we've been graphing, right? We know what the graph of that looks like. It moves back and forth, right? We might interchange. You guys remember what an inverse is? It's when you switch x and y and you solve. So we might say theta equals sine of y, and then to solve that, and I really should put this as x. I should make this x just because that's what we're used to seeing. X's and y's when we're doing this. So sine of y equals x, and to solve for y, I would have to take the sine inverse of both sides, and that would give me sine inverse of x equals y, because the sine and the sine inverse undo each other. And so we get y equals the sine inverse of x. So we're going to learn how to graph that today. That's what we're going to do. So these two things, graph inverse functions, and then find values of inverse trigonometric functions. Okay? So for the sine function, I want you guys to do the following. Graph the function. Everybody graph it into your calculator. Y equals sine of x. Tell its domain and range. Switch the domain and range to find its inverse and graph the inverse. I'm going to give you guys a few minutes in your groups. I want you to see what that's going to look like. See if you can come up with that in your groups. Okay, so, yeah. Okay, you guys, I want to talk about these. We are going to graph the sine function right here first, sine of x. Okay, I'm going to name some points on the sine of x. Okay, I'm going to name this point. What's this point right here, you guys? So we're going to go 0, 0. What's this point right here? Pi halves, comma 1. What's this point right here? Pi, comma 0, yeah. What's this point right here? 3 pi halves, comma negative 1. And let's go the point right here. 2 pi comma 0. And I want to get a couple of negative ones. So let's go this one right here. Negative pi half is negative 1. And this point right here. Negative pi comma 0. Oh, whoops. Negative pi comma 0. And let's name the last two. We'll just say that. What's that one? Negative 3 pi halves. Negative 3 pi. Negative 3 pi halves comma 1 and negative 2 pi comma 0. Okay, now I want you to see that right here, naming these points right here. I want you to see that when we graph the inverse of this, an inverse, let me just remind you, is just switching the x and the y coordinates. It's switching the domain and range. So I'm going to make this one into a table of values, my inverse. I'm going to call this sine inverse of that, sine inverse, okay? And so when we do sine inverse, we switch which ones are the x and y coordinates, okay? 0 comma 0 does not change, does it? But what's the pi halves comma 1 switch to? 1 comma pi halves, right? What's the next one? 0 comma pi. What's the next one? Negative 1 comma 3 pi halves, and what else? 0 comma 2 pi. Let's graph these on this thing. Now keep in mind, you guys, what pi divided by 2? Pi is about 3.14 divided by 2 is about 0.78. Okay? So when I graph, okay, I'm going to graph 0 comma 0 right here. I'm going to use a different color. Let's go green. I'm going to graph 0 comma 0. I'm going to graph 1 comma pi halves. So pi halves is 1 point, what is that? 1 point what? What's pi divided by 2? 1 point what? Pi divided by 2, what? 1.57. So I'm going to go to 1, which is about right here, comma 1.5. Somewhere right in here, right? Okay? And then I'm going to go to 0, comma pi. Pi, this is 1, this is 2, this is 3, so 0 comma pi is going to be somewhere right in here, right? Well, because I'm trying to come up with a decimal equivalent right here. I have 1 comma pi halves, and I need to know about where pi divided by 2 is on the line, so it's about 1.57. Yeah. Well, I could switch the window. Is that what you're saying? We could switch the window. We could go to window, and instead of up here, we have, we can go to -5. Actually, we could, yeah, -5. Whoops. +5, okay. X scale is 1. We could do that. -2 pi, -2 pi. And +2 pi. And the y scale is pi divided by 4. And we could graph that. We still have our, now that changed those, I'm going to erase those red ones because it changes those a little bit right there. Okay, because the scale changed. So now, oh, and we're going to have to erase these because our scale changed going up, right? So now I'm going to have, at pi halves, I'm going to have what? 1 comma pi halves, right there. Oh, 1 comma pi halves would be right here, right? Sorry, those are pi fourths. So 1 pi halves right there. 0 comma pi. So 0 comma 1, 2, 3, 4. This is pi right here, right? And then this is going to be -1 comma 3 pi halves, and this is going to be 0, 2 pi. So it's going up like this. And if I go the other direction, it's going to be out here. And then it's going to be right here. And then it's going to be right here. Then right here, so it's going to go like this. Right? That is our inverse of the sine function. Why doesn't it do it all on the calculator? That's the question I was just about ready to ask. How many of you guys have graphed the sine inverse on your calculator? And it only graphs part of that. Why is that? Say that again. It's not a function of the way I have it done right here, right? Because it doesn't pass what test? It doesn't pass the vertical line test, right? Like this. So if it doesn't pass the vertical line test, it's not a function. We want the sine inverse function. So what do we have to do? We have to restrict something. What do we have to restrict? Let me ask you this. On the sine function, where would I restrict the domain from so that when I turn this, I would have the inverse? So it's a function. What if I only drew this part of the graph right there? Okay, so it passes the horizontal line test. Remember, if a function is 1-to-1, then its inverse will be a function. 1-to-1 means it passes the horizontal and vertical line test. Would this blue part right here pass the vertical or the horizontal line test? Yeah, and when I graphed it over here, it would be this part right here. It would be that part right there. Does that pass the vertical line test? Yeah. Actually, it kind of goes more like this. Okay, and that passes the vertical line test. That's why it only graphs that. Does that make sense, Coulter? Because they have to restrict the domain so the function, so its inverse has, so the inverse is a function. What was that? Let's go right here. Okay, is the inverse a function? No. If not, tell what you would have to do to make it a function. Restrict the domain of the original function, right? So the domain of y equals sine x would have to go from where to where? No, negative pi halves to positive pi halves, right? And that would restrict the range of that function to be would be -1 is less than y is less than +1, right? So when you do the inverse, which is y equals sine inverse of x, your domain and range switch. So your domain becomes -1 is less than x is less than 1, and your range becomes negative pi halves is less than or equal to y is less than or equal to positive pi halves. Do we understand that? That's really important. Write that down. That part right there. Your inverse. Your inputs have to be between -1 and 1. Your outputs can be between negative pi halves and positive pi halves. Okay, I'll make it bigger. I have to move it up. Is that big enough? Okay, so you guys, on the original function I had up here, on this original function, the domain of y equals sine x was negative pi halves to pi halves. The range was -1 to 1. All you do is switch those for the inverse. The domain becomes -1 to 1. The range becomes negative pi halves to positive pi halves. Okay? So when I say find the sine inverse of 2, can you do that? What if I put 2 in for this x right here? Sine inverse of 2. Can I do that? What does x tell me to be between? It has to be a number between -1 and 1, right? Okay, so if I said find the sine inverse of 2, that's outside my domain, right? That's impossible to do, okay? Huh? Well, if my original function was, but if I'm given just the sine inverse of x, then no. Okay? If we gave you a function where the amplitude was changed, yes. Okay. Yeah. Yeah, the range is pi over 2 right here. Okay? And your answer is always going to be between negative pi halves and positive pi halves. And by the way, that's about negative 1.57 is less than or equal to y is less than or equal to positive 1.57. Somewhere in there. That's kind of a that's an approximation. Okay? So your answers will always be that on the sine function. Any questions there? Okay. So the question is right here. Number 3, find the arc sine of 1/2. Remember, we use arc sine instead of sine inverse sometimes. It means the same thing. So everybody in your groups, I'm going to give you a minute. Find the arc sine of 1/2. Go. What am I essentially asking when I say find the arc sine of 1/2? Yeah, I'm saying the sine of what angle is 1/2? So if we're going to give the answer in radians, what would the answer be? Pi over 6. If it's in degrees, what would the answer be? 30. So it depends on what they want your answer in. So pay attention to that on your assignment today and then on the test. Okay? So it's all it's asking for is 30 degrees. Now, is there another answer besides 30 degrees? Actually, think about this, you guys. What did we talk about the answer can be between?
It only can be between 1. Like,
no, the answer can be between, right here, negative pi halves and positive pi halves. What is that in degrees? What's that in degrees? Negative 90 degrees to what? To 90 degrees. I can only take answers between negative 90 degrees and positive 90 degrees. And so if you look over here, 5 pi over 6, or 150 degrees, has a sine of 1/2. However, it's not between 90 degrees and negative 90 degrees, which is the first and fourth quadrant, right? The only thing is, I got to caution you, when you name an angle in the fourth quadrant, it has to be a negative angle. So this is not 300 degrees right here. What angle is this? Negative 60. And this is not 270 degrees. This is negative 90. And this is, the 315 degree is negative 45 or negative pi 4 if we're in radians. And this is negative 30 or negative pi 6 in radians, right? Okay, so just keep that in mind. It has to be between that. So when you're asking the question in inverse form, it has to be like that. Okay? Let me go to the next slide. Okay. If we did the same thing for the cosine function, instead of taking time to do that right now, I just want you guys to look at this. Okay, we know the cosine function, instead of starting at 0, 0, it goes like this, right? Between 0 and 2 pi. And I could do the same thing on the other side. Whoops. So, okay, so if we did this on the other side, it gets that. Where would I restrict the domain of this one between so that it passes the horizontal line test? From where to where? I want everybody in your groups, talk about it in your groups for 30 seconds. Go. Okay, what did we come up with? 0 to pi, is that what everybody agrees on? Yeah, because look, right here, from here to right here, if you made a horizontal line anywhere in there, it's only going to cross through it once, right? I can't take between negative pi halves and positive pi halves like we did on the other way because it would cross it twice, right? Does that make sense? So the cosine inverse function is different. Okay, the cosine inverse function is different. So we're going to restrict it between 0 and pi. So the inverse, cosine inverse of x, what's the domain of this one going to be? Between what and what? 0 and pi. And what's the range going to be? Oh, I'm sorry. We got to switch these, right? We got to switch these because I'm doing the inverse. The range is between, the answer is going to be between 0 and pi. And what's my input going to be between? Negative 1 and 1, right? Okay, because look, it only goes up to 1, down to negative 1 right here for the range, but the range of the regular function becomes the domain of this function because we switch them, right? Okay? So, and then this one went from 0 to pi for the domain of the y equals cosine of x, so the inverse would be range is between 0 and pi. Okay, so you just switch those. So what if I ask this question right here? Wait, let's do this. What if I asked you for the cosine inverse of negative root 3 over 2? What if I asked you for the cosine inverse of negative root 3 over 2? In your groups, discuss what you think it is. Go. Say the answer in radians. 4 pi over 3. If you agree, raise your hand. No one agrees? Anybody have a different answer? 5 pi over 6. If you agree, raise your hand. A couple of people agree. 5 pi over 6? Yeah, it's dawning on more of you now. It is 5 pi over 6. Good job, Julie. Okay, look. At 5 pi over 6, what's the x value? Negative root 3 over 2. Remember, cosine is defined to be the x value. Okay, now, can I be over here in this quadrant? What did we just talk about the domain or the range the answer can be in? 0 to pi. Is that between 0 and pi? Yeah. Here's 0 degrees. Here's pi. So a cosine function, the answer has to be in the first or second quadrant, right? Write that down. The answer to a cosine function has to be in the first or second quadrant, or between 0 and pi, or between 0 and 180 degrees, however you want to say it. So the answer to this is 5 pi over 6, or 150 degrees. Yeah, the cosine inverse. The answer to a cosine inverse function has to be in the first or second quadrant, or between 0 and pi. Okay, we got that? And what does the answer of a sine inverse function have to be between? Okay, the negative fourth quadrant and the first quadrant, okay? Negative fourth quadrant and the first quadrant. In other words, between negative pi halves to positive pi halves, or negative 90 degrees to positive 90 degrees, okay? Now, so let's go to the tangent function. We're going to talk about the tangent function. We know already that the tangent function exists of a bunch of things that go like this, right? And then there's an asymptote, and then it repeats that pattern. What's going to happen if I continue to repeat that pattern? Is it going to pass the horizontal line test? No, so this one cycle of the tangent function is going to be where we're going to restrict it to get the inverse, right? So the domain of this one is between what? Negative pi halves and positive pi halves, right? And the range is between negative 1 and 1, right? So if I find the inverse tangent inverse, oh yeah, it's not. It's all real numbers, isn't it? All reals. Sorry, I got kind of a hurry. Good job, JD. Okay, so it's all reals. So y equals tangent inverse of x. What's the domain going to be, you guys? Keep in mind you switch them. All reals. Remember, the range of this one becomes the domain of this one. And the domain of this one becomes the range of this one. So the range has to be an answer. Your answer has to be between what and what? So the answer to an inverse function has to be between negative 90 degrees and positive 90 degrees. It has to be like a sine. It has to be in the first and fourth quadrant, the negative fourth quadrant. Okay? But guess what? Can I ask you this question? Can I say, what is, y equals the tangent inverse of 3? Can I ask that question? Can I ask that question? Remember, for a cosine, I couldn't ask that question. Why? Yeah, it was outside the domain. I had to put an answer in between. -1 and 1 on the cosine, but on the tangent, it can be any real number. Your input can be any real number, so that number can be any real number. Well, we don't cut the range goes of this function right here. It goes on forever. It goes up forever and down forever. So the range of this one was all real numbers. So when we switch the domain and range, the domain of this one can be all real numbers. So any number you can put any number in for a tangent inverse. But your output is going to be, your answer is going to be what? Between negative pi halves and positive pi halves. You got that? Okay, so your answer is going to be between those. And you know what? We don't worry about the cotangent, cosecant, and secant right now. I'm just going to give you a couple examples. Okay, let's do a couple examples, and then I'm going to let you guys do the homework assignment. Okay, here we go. First one, cosine inverse of 0. Cosine inverse of 0. Find it. What is the answer? Pi halves is the answer. Because we're asking you guys, remember, the cosine of what angle x equals 0. Cosine is defined to be the x-coordinate, so you find an x-coordinate of 0. Unit circle. Right here at 90 degrees. The x-coordinate 0. Or if it's in radians, we call it pi halves. Is that between 0 and pi? Yeah, so that's a legit answer, right? Okay, next question. The sine inverse of 0. The sine inverse 0. When your group knows the answer, raise your hand. Okay, what's the answer? 0 or 2 pi? What is 2 pi work for an answer? It's too big, isn't it? Say that again. It's in the same place, but is it between negative pi halves and positive pi halves? Yeah. So the only answer that works is 0, okay? The only answer that works is 0 radians or 0 degrees, because 2 pi is not between negative pi halves and positive pi halves. Your answer for sines have to be between negative pi halves and positive pi halves. Okay, next one. Cosine inverse of 5. Cosine inverse of 5. I don't know. I just did. Why can't I do it? Okay, what do my inputs have to be on cosine and sine inverses? Between negative 1 and 1. So this one's impossible, right? This one's impossible because this number right here has to be between negative 1 and positive 1 to ask that question for a cosine inverse and a sine inverse. Okay, here's the next one. Tangent inverse of negative 1. Tangent inverse of negative 1. Tangent inverse of negative 1. When you think you got the answer, raise your hand. Okay, what do you guys think it is? Say that again. Negative pi fourths? What do you think it is? 7 pi fourths?
It's just negative.
So what is it, 7 pi fourths or negative pi fourths?
Negative pi fourths. Negative pi fourths.
Why is it negative pi fourths and not 7 pi fourths?
You don't go all the way around. You just like,
Yeah, because the answer has to be between negative pi halves and positive pi halves. Is 7 pi fourths between negative pi halves and positive pi halves? No, but is negative pi fourths between those, right? So the answer is negative pi fourths, because at that point, y divided by x is going to be negative square root 2 over 2 divided by positive square root 2 over 2, which is a negative 1, right? And your answer has to be between negative pi halves and positive pi halves, and 7 pi fourths is not between those. Well, if you look at the unit circle right here, tangents defined to be y over x. So negative root 2 over 2 divided by root 2 over 2 is negative 1, right? So it's this point right here. But to get it, you have to go in the negative direction. So that's negative pi fourths, because your answer has to be between negative pi halves and positive pi halves. It has to be in the first or fourth quadrant, but if it's in the fourth quadrant, you have to go there to get in the from the negative angle. Huh?
north to southwest.
Yeah, is that right? Okay. Here is your assignment. Most of your assignment, you guys, notice I said on 14, 15, and 16, you don't need to graph it. The instructions say to. Most of your assignments can be doing what I was just doing right there at the end. See if you can figure those out, the inverses.